Good day, Sir William and everyone. We are Group 2 and we are going to present to you the drawing plans of the Xavier University Chapel. Short background: the University Church provides a venue for students, employees, and other churchgoers to serve and share reflections and faith and reason, especially when there are pressing issues relevant in the spiritual and conscience formation of the members of the community. It is a place that provides pastoral care to both members of the university community and to those from outside who regularly comes to church for spiritual nourishment. With that, we are more motivated to work on this structure given these following objectives. So here are the objectives of our project. Our main goal is to make 4 drawing plans, and these are the following. First is the architectural plan, the structural plan, electrical plan, and plumbing. We have decided to not include the mechanical plans as agreed with Sir William, since it is not applicable in our state.
Good day, I'm May Choherong, and the first main segment of this video is the architectural plan. This part of the architectural plan is the architect's perspective, which was designed using the SketchUp software. The architect's perspective is the representation of three-dimensional objects on a two-dimensional or flat surface. This recreates the position of the observer relative to the object and shows the depth of the objects. Next is the location map or the site development plan. The location map is the quote-unquote where aspect of your planning application. It shows where you are proposing your development and will include a fairly large area around the development site. So basically, this is the Xavier University Chapel, which is found inside the campus. Next here is the floor plan. Floor plans are scale drawings that show the relationship between rooms, spaces, and physical features viewed from above. They provide a way to visualize how people will move through the space. And as we may observe, the offices, the altar, the hallway, the confession rooms, and so on are included in this part of the plan. We can also observe that the dimensions of the chapel are included so that we may have a clear perspective on how specific the measurements are based on what we have estimated.
Hello everyone, I'm Aloran Oro and I'm here to show my contribution to our group's making of the plan of the Xavier University Church. So what I had done was arrange the the outputs from our fellow group members. Then I put the sectionings and also dimensions. So firstly, we have the different types of elevations. We have the front and rear and the left and right. As you can see here, you can see the dimensions and also the different elevations as well as the sections. So firstly, we have the front elevation. We have the natural ground line, ground floor, final level, the walkway roof apex, top of the upper roof, gable roof eave and ridge. Then we have the roof apex and also the apex line. So the apex line is the topmost of the structure. We have the roof apex, the topmost part of the roof. We also have the gable roof ridge and the gable roof eave. So the ridge is the topmost part of the gable roof and the eave is the bottommost part. Then we have the top of the outer roof. This is here. Walkway roof apex, it is the back of the church. Then the ground floor, it is elevated. So that's it for the elevations. And here we have the rear elevations, which is basically the same, but only at the back of the church. Then we have the left side elevations. And now it is now a different sectionings. We have only one since it is a different view. and the same elevations as you can see. And here we have the floor plan. You can see all of the different sections as you can see right here, and also the different measurements and dimensions.
Okay, so moving forward to the scheduling of doors and windows, we have 13 types of windows and 2 types of doors that can be found in the chapel. So for window one, which can be found in the main side of the chapel, which are the sides, it is a type of steel aperture that is fixed. So there's actually no glass that can be found here. It's mostly steel and it's designed this way. So it's so this allows open air to go in the chapel. So for window 2, it is a stained glass that is fixed in front of the chapel, and there's actually four types of stained glass that can be found in the front of the chapel, which is also the same for window 3, 4, and 5. So window 5 is the main window that can be found in the center of the chapel, while window 4, 3, and 2 can be found right beside window 5. And then if we move to the side a bit, we will have window 6, which is also a stained glass and is fixed in the side of the chapel, which is also tall and long and slender compared to window 2, 3, 4, and 5. Then at the side of the chapel as well, we also have window 7, which is a smaller version of a stained glass that is fixed on top of the chapel. Then if we move to the rear end, we have another stained glass, but this time it's fixed and circular, which is right around 7 meters high. And beside it would be two window lines, which is around 5.2 meters high from the ground line, which is also circular and also stained glass fixed. So now moving to window 10, 11, 12, and 13, which all can be found at the back of the chapel and are no longer stained glass but rather crystal glass that are casement style, which means it can be opened and closed. These windows are located more on the back of the chapel, which contains the lobbies, the church, the offices, uh, and the priests or fathers' office. So there are four different sizes of it, which is can be seen here for window 10, then for here for window 11, then window 13, and window 12. So window 10, 11, and 13 are the same height above the ground line, while window 12 is around a bit higher, but then it's also smaller, so they are all horizontally like equal. So that is for the windows. Now moving to the doors, we have the main doors, which are technically gates on the front and rear of the chapel, which serves as the chapel entrance. So these are still gates. So they're yes, these are still gates, and it's 5.6 meters above the ground line, which is technically there are stairs, so that's why. Then it is 5.5 around 5.5 meters high, and can be opened in the middle. So it opens like two doors together. So these are the gates. And then we have door two, which can be found at the office areas at the back of the chapel. So they have all the same type of doors going in and out from the lobby, the offices, and everything. So these are wooden doors, and it's around 5.1 meters high and 3.1 meters wide. So that is for the scheduling of the windows and doors. There's lots of windows, knowing that this is chapel and they are mostly stained glass, bringing this architectural and artistic views.
So, good day, sir. I am Daniel Justin Padilla, and today I'm going to explain to you about the roof plan of Xavier University Chapel. And later on, I am also going to explain to you the roof framing plan of the chapel. So, to start off, I also followed our dimensions, and kiputang gistated din ako ang slope, which is the which is basically the inclination of the roof, or more or less the rise over run sa atop, sir. And separate na ko ning duha ka slope, kaning nga slope ug kaning nga slope, since ang atop sa Xavier University Chapel is like monitor roof based sa Google. Pero basically more gyapon siya katong simple na sa tawag na gable type roof, itong triangle lang. Pero ang sa Xavier University Chapel lang kay naay murag ni patong, isa na pod ka naay ni patong nga isa na sad ka gable roof. Kani nga design is gibuhat ni nga design tungod kay para napoy suga or pwede pod hangin makasulod dari sa sulod sa simbahan. Pero kung tanawon niyo po ninyo ang sulod sa simbahan, dili siya maklaro, straight kun gyapon siya, straight gyapon siya. And here gibutang nako ang section sa columns, which is kani sa A, B, C, and so forth. Kani dayon section din ani is kani nga part ito dari. And kaning tulo ka slope dari, kaning nga tulo ka atop is basically ang likod sa simbahan, which is katong mga rooms na dayon sa pare, mga butanganan and so on and so forth. And ang slope ani is panaog, or ang inclination day ani nga atop is padulong dito or padulong sa murag parkinganan facing the field. And tulo ni sila kabuok since ang tunga ani, as you can see dari, murag gibot niyan og beam or wall ba na? No, it's a wall. Gibot niyan og murag wall, some type of wall here. Dari pod pusa na separate siyang tulo. And basically that's it. Thank you.
Okay, so now for the foundation plan, we have three types of foundation that can be seen, which is the main foundation, the secondary foundation, and the tertiary foundation. So for the main foundation, it is labeled as foundation 2 with column 2, which is found right around here in the chapel, all the way here, and also in this side here, until here. So these foundation beams are the one who will be carrying the whole chapel, which is all the way in the main chapel hall. The secondary foundation is labeled as foundation 1C1, which is near the foundation 2, and it's mostly holding up the sides of the church, not including the main church in the main hall. So it's located in the sides, the outer sides as well, also in the inner side. And the secondary foundation can also be seen here in the entrance side, and also at the, yes, that's it, only in the main entrance side. Then we have the tertiary foundation, which is to add additional support to the entrance and also to the sides and at the back as well. So that is for the foundation plan. The beams are mostly horizontal, which indicates the type of foundation here to be more of a one-way type of foundation and type of beam. And then the main foundation here in foundation 2 and C2, it is morely horizontal because it's one way, and the beams would be starting to connect to the roof plan. So yes.
So, hello everyone. I am Ricky Balantayo, and let's now talk about the column schedule and footing details of which is under the structural plan. So, column schedule means the table containing all the details of column required during the construction process, and it contains marking of column, size of columns, numbers of bars, diameter of bars used, etc. So seen on our plans, we have both sizes need 8 16 millimeter diameter vertical bars. And we have two different types of columns. C1 is 0.35 by 0.35 meters, and C2 is 0.30 by 0.30 meters, where both sizes need 8 by 16 millimeters of diameter vertical bars. For the footing schedule and detail, there are different components such as size and shape of footing, depth of footing, concrete detail information, reinforcement details, and more. The footing is the bottommost element of the foundation that transfers the load of the structure to the underlying soil. The drawing shows two different sizes, which are a square footing, which is having a dimension of 1,600 millimeters by 1,600 millimeters for footing 1, and 1,400 by 1,400 millimeters for footing 2. The footing includes steel reinforcement to improve its strength and keep capacity to carry loads. The drawing specifies the type, size, and quantity of the steel bars to be used. Lastly, the footing sits on a 600 millimeter thick gravel bed with 10 millimeters deformable reinforcing steel bars, and at 0.60 millimeter center to center, which helps to distribute the load over a wider area and provide drainage. So here is the typical WF detail and footing section. So next is for the slab detail. For the slab detail, we have two different slab designs, a two-way slab and a one-way slab, which are both made of reinforced concrete and a common building material that consists of concrete reinforcement with steel bars. So for two-way slab or S2, it bends in two directions. A two-way slab is supported on all four edges and bends in two directions, typically referred to as a positive and negative moment when loaded. This bending is accounted by placing reinforcement in two perpendicular directions throughout the slab, and the top rebar placement is shown in the top bars plan and one for the bottom bars plan. Reinforcing the top rebar for the two-way slab is 10 millimeter diameter DSBS DSBS at 300 millimeters center to center. And this type of slab is efficient for square or rectangular shape areas where the length to width ratio is less than approximately 2. Next is for the one-way slab. It bends in one direction, which is typically supported on two opposite edges and primarily bends in one direction when loaded. The reinforcement is placed perpendicular to the direction of the bending. Reinforcing the one-way slab is 10 millimeter diameter deformed steel bars spaced at 450 millimeters center to center. These slabs, or these types of slabs, are efficient for rectangular shapes area where the strength, or rather the length to width ratio is greater than approximately 2. So the choices between a two-way slab and a one-way slab depends on the specific reinforcement of the project.
I am going to now explain the roof framing plan of Xavier University Chapel. And to start off, ang gibutang aning sa roof framing plan is basically the roof beams and the rafters and the inclinations of the roof. So gi-highlight na ko yellow ang mga roof beams para pod maklaro, and they are connected to the columns of the simbahan, which are maklaro aning mga sections sa A to A taman G. So basically, kung mabantayan niyo sa sulod sa simbahan, the ceiling has the beams, which may indicate aning mga yellow lines, while the small white lines between the beams are the rafters. nga maklaro, ay dili maklaro, which dili maklaro sa simbahan. Okay na. And the reason why gi-separate na ko ang gilahi na ko ang itsura aning rafters ani aning duha sa kaning susulod is because ang design sa roof sa Xavier Chapel is Bali another type of gable roof nga gipatungan aning dako nga atop. So ang tawagan na sa Google is monitor roof. Yes. So pusa gi-separate po, as you can see, gi-separate po nako ang slopes aning isa dari kaning dako, isa ka inclination sa atop o kaning nga inclination sa atop kay lahi pod sila lahi pod sila inclination, and there are different type of roof. Yeah. So next dayon is the back part of the church, which is the more or less the rooms as gi-explain ako atong roof plan, the rooms sa mga pari and the like. So the reason why gi-separate po nako ning slope, ang tulo ka slope ani maklaro aning dari, is because in between them there is a roof beam and based po sa measurements namo, there is also there's also a wall in between them. So ang challenges na encounter nako while making this roof framing plan and katong roof plan pod is ang pag-imagination siguro. Galisod pod ko kuan pag-imagine kay naglayo ra pod kayo di naman siguro layo sa tinuod, pero basta lisod kay siya imagine sir. And gi-overcome na ko to by mangutana og engineer sir kaning alumni nga bago ra graduate, bago ra pasar sa board. So napatabang ko niya since he's an alumni of Xavier University pod, so gitudloan ko niya gimo aning roof framing plan nga kanang pang estudyante nga level, kanang masabtan natong tanan.
Next is the electrical plan. An electrical plan is the visual and drawn description of building circuits and electrical properties. It is also known as a wiring diagram or an electrical drawing. It includes lines and symbols in a layout that represents the electrical system of a property. So this is the electrical layout of the XU Chapel based on our observations as a group.
And then moving on, we have for the sanitary section, we have this is the only plumbing that we had found because it is a church and there is only a small office part of the church located at the back, and this is the only sort of plumbing that we have found. So we have a lavatory, a water closet, and a floor drain, and it can be found right here. So given the plans that we had made, the challenges we had encountered in making the building plans for the XC Church is that we do not have any means of accurately measuring parts of the structure that we could not reach so easily. Moreover, access to the building is difficult due to it being a place of worship, thus being some areas of the building being inaccessible to outsiders. So in order to overcome these challenges, we used various methods of alternative measuring. Firstly, we had used a technique called ratio and proportioning, wherein we had an object or a subject with known height, Then we put it in front of the thing that we had wanted to measure. Then we calculated it by having a ratio of the known object and a measurement of, for example, we have here this person. We measure it on the screen or anywhere. Then we have a proportion, the known height over the measured height on the picture. Then we equate it to another ratio of the building. So we have the unknown value, which is the real height, and then we have the measured height on the picture. Then we can get an approximate measure of the element that we want. And we use this for places that we could not readily reach, such as for here, we could use it for the elevation. We cannot reach that. And here, we can use that for the roof, as you can see. And since we cannot reach that easily, then moreover, we also had reached out to the PPO for existing plans in order for us to check whether our measurements were accurate enough. So, as a summary, we had done what we could in order to create plans for the Xavier University Church, and that included architectural, structural, electrical, and sanitary plans, which is what we had done to the best of our capabilities. For an architectural plan, we have the architect's perspective, the site development plan, the elevations, and also for the floor plan. Then we have, for the structural, we have the framing plan, the roof plan, and the schedules for the footings and columns. And we also have foundation plans. Then we have the electrical layout and the sanitary layout plan, which is only this part right here. And the so that is it for our plans. Thank you.